Welcome back to another STEM with Ms. Dubois video, where in today's video, I'm going to be explaining the planes and axes in Fusion. And this can probably be applied to other math concepts as well, but I'm going to be specifically focused on the use of planes and axes in Fusion. So, what are the axes? Fusion has three axes: an x-axis, a y-axis, and a z-axis. The x-axis goes side to side and it determines the width of an object. The y-axis goes up and down and it determines the length of an object. The x and y-axis are what you might be most familiar with in math class because you see this starting in Algebra 1 or even probably other math. So if you're familiar with any of these axes or a combination of these axes, you're probably going to be familiar with the x and y axes. Now, the z-axis, this might be the newest one for a couple of y'all or some of y'all, especially if you've never worked in 3D or have never thought about 3D type stuff before, or just in general, because it can be confusing. So the z-axis goes up and down, but in 3D, and this determines the height of an object. So let's break this down even more. In Fusion, as you see right here, this is a screenshot from Fusion. I'm going to label these axes. The red axis is the x-axis. The green axis, the one that's going up and down, is the y-axis. And the blue axis, the one that's going up and down, but it determines the height, is the z-axis. So, what are the planes or planar faces that Fusion calls it? So a plane is a flat 2D surface created by two axes. It's basically the scope or like the layout that when two planes intersect, what they create in a way. So the planes are the XY plane. In Fusion, I like to call this the top plane because it shows the top and bottom views of an object. The YZ plane, I call it the right plane because it shows the right and left views in Fusion. And the XZ plane, I call it the front plane because it shows the front and back views of an object in Fusion. Once again, these are all based on stuff in Fusion. So let's see what they look like in Fusion. Right here, we have the Z and X axes making the XZ plane, right? And this is also what I call the front view or the front plane because it's showing you the front view of an object. This right here is another screenshot from Fusion. It's showing the Z and the Y axis. So it's called the YZ plane. You always do the letter that's earlier in the alphabet first when talking about planes and stuff. So this is the YZ plane. This shows the right and left view of an object. And then this axis right here is the XY plane. This is what you might be most familiar with from math class. And essentially, this just shows the top and bottom views of an object. Okay? So let's break this down and see this in Fusion. So here I just have a blank Fusion document with nothing on it. I'm doing that on purpose because in this tab, I actually have a cube. And I'll explain why in a second. But here we have the z-axis, right? You can see that when I put my cursor over it, this area right here highlights it. So that's telling me that it's the z-axis. This is the axis that goes up and down. I have my y-axis, which is going up and down, but on a piece of paper. And then I have my x-axis, which is going from side to side or horizontal. So, yeah. Now let's talk about the planes, okay? I'm actually going to turn off some of these planes so you can see what I'm talking about when I talk about the front view, right view, whatever. This cube right here is going to be your best friend because this will help you understand the views and the planes and stuff. Now, right here you see that if I look at this, I have the right view showing, and that's showing this plane. If I turn on the other planes, as you can see me doing right here, you can't see those other planes. But if I click home, whoa, you see those planes. So let's try that again with the left view. Whoa, I don't see any of those planes again. That is why I call the Z-Y axis the left or right view plane because you can only see the left and right view of an object. Now let's go to home and let's turn off the YZ plane and focus on the XZ plane, which is what I call the front and back plane, right? Because if we click the front, that's the only plane we're seeing. Even if we turn on the other planes, let's go all the way to the back. Oh, we can see the other planes. Oh, we can see the other planes. But if we go to the back view, we can't see those other planes, even though we know they're turned on because these eyeballs are dark gray and they don't have a cross through them. That is why I call the ZX axis, or the ZX plane, sorry, the front and back view. Let me click home again. Let me turn off this and this. Now the plane that you're most comfortable with, presumably if you've taken Algebra 1 and understand and have retained anything from Algebra 1, typically, at least in the state that I teach, Algebra 1 does teach this. And in the state that I grew up in, which is New York, this is also what I was taught too. So let's go to top view, and we see the XY axes, which is why I call this XY plane the top plane in Fusion. And if we go to bottom view, look, and I bet if we turn on these other planes, oh no, what's going to happen, right? Oh, we're not seeing these other planes. We're not seeing these other faces, right? If we click home, oh, look, we see the other planes. If we click top view, oh no, they're out of our vision or perspective. We can only focus on the XY plane. So let's see this a little bit in action of how an object might lie on a plane. So here I went to Untitled, and here I have a cube. And I will show a real life version of how we can see this in real life, because I get that this is abstract, in the next clip. But here I have a cube, right? So I have a cube that shows the front that's on all three views, right? The height of the cube is going up and down on the XZ plane. Also, the height is shown on the Z axis. On the YZ plane, it's showing me, crossing the YZ axis and the YZ plane. We can also get a better view if I go, hold on. We can also get a better view if I focus just on this area of things, right? You can see the Y, hold on, let me move this. Let me press escape. Okay, so we have this, we have the Y-axis being shown right here. This determines the length of an object, and then we have the X-axis right here in red, determining the width. So that is a little bit of this, but let's once again see this with a slightly different object where we can really see the different planes. So we're going to go to this, and I'm going to create something. Let's create a rectangle. I'm putting something, I'm doing 4, nope, that's way too big. Let's do 0.2 by 1 inch. Okay, I'm gonna click finish sketch. I'm going to click on this face. I'm going to click extrude. And I'm going to do 0.3. Here we have an object that is showing on all three axes, right? Now, if I do the top view, hold on, let me do the top view and a normal-ish view. The length and the width are being shown right here of the object. And then if I do, hold on, I want to zoom out actually. There we go. And now if I just do the front view, you can see everything right here. And if I do, let's just do a front view, you can also see the height and the width. Or if I do a left view, which is also the same as a right view, you can see the height and the length of the object. And that's what the planes and stuff in Fusion are. We can see a version of this in real life in the next clip. So here we have a Rubik's Cube that's mocking or mimicking the cube that I have on Fusion. And essentially what you can see is if I go over the top view of the plane, let me zoom out a little bit, we have our x-axis, sorry it's poorly drawn, and our y-axis. Our x-axis is going from side to side, and our y-axis is going up and down. Then once I bring this into the 3D view, we can see that this pen that's representing the z-axis is going up and down, determining the height of the object, right? So let's just rotate this. And I have the y-axis and now the z-axis in place. And if this were perfect, you could see that you could only see the right view and the back view of the object. And this would show the YZ plane because we can see the pen, which is representing the Z-axis, and we can see the Y-axis, in the back. Now, if I were to rotate this again, and I would put it right here, we could see the front view, which is represented by the yellow face of the Rubik's Cube. And the front plane, or the front view, is showing the XZ plane as indicated by the blue pen and this black horizontal line representing the x-axis. Heads up, this is not sponsored by Stouffer's. I wish it was, but this was the closest thing that I had to what I modeled in Fusion earlier in the video. Anyways, so here we have a box of Stouffer's on our imaginary coordinate system, and you can see on our x-axis going from side to side is showing the width of an object. We have our y-axis going up and down, which is showing the length of our object. And we have our blue pen representing the z-axis, determining or showing the height of the object, right? So if we go and do a top view of the object, we see our x-axis that determines the width, right? It's going from side to side. And then we have our y-axis that is determining the length, and it's going up and down, okay? And this is also our top view, right? Because we're focused on the X and Y views, and we're also looking at the object top to the bottom, essentially. If I could show you the bottom of the object, I would. It would just show the same exact view. Now, we're going to rotate this object just a smudge, or actually 90 degrees. And then I'm going to show you the right view. So, in our right view, we have the y-axis and we have the z-axis. The z-axis is represented by the pen and the y-axis is going this way, right? But that's just showing you the right view because this is the right-sided view of the object. We could show you the left view of the object and it would show you the same exact thing, except I actually used the Stouffer's box to make dinner. So yeah, but you're only going to see the YZ plane and not the X plane, as you can see right here. Now, if you rotate this again 90 degrees and we focus right here, you can see the XZ plane, right? The X-axis going from side to side and the Z plane determining or showing the height of the object. And this would be the front view because you're seeing the very front of the object. And that is how you can see these axes and planes and faces in real life. A plane and a face are the same thing in Fusion. You might be wondering, why am I explaining the planes and axes to you, right? Well, it's good to know for Fusion, right? Because you'll see it every single time you open Fusion. Also, it helps with understanding how to use certain tools and functions in Fusion the further and more in depth you get into using Fusion. So having a base level or base layer of understanding of what these planes and axes are really helpful. Plus, if you make a sketch in one of these planes, you can understand what two axes you're making that sketch on, what that plane is, and how that can help you extrude or do other functions and features in Fusion. And that was, what are the planes and axes in Fusion? I'm STEM with Miss Dubois. Thank you for watching. I hope you have a great day and a great life. Bye!